Okay, good afternoon, everybody. Thank you for joining October 2023, Collaborating to Reduce and Control Workplace Exposures. And this is the last webinar in this series. It's about the Airborne Hazard Management Program, Reducing Exposures in Mining. What I'd like to start off quickly with, I just want to read a poem that I came across because we had Remembrance Day a little over a week ago. I came across a poem that I just want to share with you all. It's called I Love This Land, and it was actually by a First Nations soldier who'd fought in the First World War. And the poem it's part of The World Remembers, and the First Nations person was from the Mississaugas of the New Credit First Nation. And so I just thought it would be appropriate to read this. It's called I Love This Land. You were and always shall be my brother. We were all the same color wrapped in the flag of this nation. My blood flowed as freely as yours, mixed in the fields. One could not be distinguished from the other. Yet when we came home, when the nation's colors were removed, difference became apparent, not between you and me, God willing, never, but in the eyes of those for whom we laid down our lives. Oh, we still stood shoulder to shoulder in the parades, but the government thought that your life was more valuable than mine. So you were given land property while I waited and waited. I know what you were given was not enough for what we endured. Still, it was much more than I. I am not envious of you, brother. I believe you deserve even more than you received, but it hurt me badly. I am not ashamed to say I cried, and why not? I bled, I died, I killed. Why does my country think I am unworthy? The enemy I fought could never be as cruel as the people I came back to embrace. I gave so much, lived through so much, and then you who I would give all for, you pushed me aside as if I was inconsequential. I feel as if I have been spit upon by one I honored. Do I feel good having to ask you for what should have been given long ago? No. In fact, I am a little ashamed to ask for justice in this, for I never want war for money, for glory, for reward. I went because it was the right thing to do, and God forgive me, I would go again. This may seem an old wound to you, but it is a wound that never heals, for it is a wound to my people's heart and soul, an insult to our pride, and we deserve so much better, especially from you. Okay. So what I'm going to do is provide some introductory slides to this session. And there's the program with all the speakers. And I also just want to say a lot of really good information through these hyperlinks. The recent mining vehicle powertrain conference, you'll see a lot with regard to diesel emission is here. And I've also provided a hyperlink to the last session, and also the hyperlink to the presentation that I gave. This is really about the Airborne Hazard Management Program, and I provided hyperlinks there to the program as required under Section 82 of Regulation 854, but Scott's going to speak to that. I just thought I'd start this off and talk about the case that I've been working on. This is a miner that actually worked underground, and he sprayed paint for around about 4 years. Quite a lot of time spent spraying paint. And when I looked at the actual safety data sheet for this spray paint, it contains between 10 and 20% lead chromate, and also about 50% xylene. So lead chromate, obviously you've got the lead, which is highly toxic, but the chromate is in a hexavalent chromium form. So if you look at the ACGH TLV, which is quite a bit lower than the ministry, the Ontario exposure limit, you can see how low that is. And this person was spraying paint, and he got very sick with kidney disease. So lead chromate is also known as chrome yellow. It's been used for centuries as a pigment, but it's highly toxic, containing lead and hexavalent chromium. Think Erin Brockovich. So I guess the question is, how could this happen? Who was providing oversight? And if there was a chemical review and approval process, this most likely would not have happened. So OHCOW has a control banning landing page where you can actually use control banning before the chemical is even brought to site to figure out whether or not it can be used safely. So I just want to quickly talk about occupational exposure limits. They are not fine dividing lines between safe and dangerous concentrations of chemicals, but rather they're best used to assess the quality of the working environment, indicate where appropriate control measures are required. And some chemicals, you can't really identify a threshold. We really need to make sure the levels of exposure is low as reasonably practicable. When we think about all of the exposures, typically exposures follow a log normal distribution. And that means we need to collect enough samples to do good statistical analysis. And there may be situations where worst case monitoring is required. Just throwing this up with regards to diesel particulate matter and elemental carbon. This is from a survey of mines, and basically Dr. Melanie Norman Gorman-Ning actually did some data analysis, and you can see there is a downward trend of elemental carbon. So if you'll see that in 2018, it went down to 0.03, yet the ministry is setting a limit of 0.12, which is quite a bit higher than what that level has come down to. But an airborne hazard management program, it's not really just diesel exhaust. We've got to think about other airborne hazards, such as lead, which I talked about, and also respirable crystalline silica. And so this is from the same data set that was shared. You can see the reverse happening here with silica. There's actually an increase in the exposures. So I've just compared the silica exposure to the Ontario limit, the OHSA, the American limit, and also the ACGH limit, which is what British Columbia follows. So if we were to look at the ACGH limit, there's a lot of exceedances again for respirable crystalline silica underground. And I guess if we're thinking about exposure limits, we should really apply the additive formula. So we really need to look at all of the exposures together, divide them by their occupational exposure limits, and then those factors should be less than 1. That really comes into play as well. The ministry website does also refer to adjusting exposure limits for irregular work shifts. So we use the Quebec model, and I just want to say Martin Albinger has done a lot of work on this for OHCOW. So this hyperlink actually goes to the OHCOW tool there. A newer standard, or a revised standard, EN 689, workplace exposure, measurement of exposure by inhalation to chemical substance agent strategy for testing compliance with occupational exposure limit values. It's a good document, and it actually streamlines the sampling program. So occupational hygienists on the call might want to look closely at this and think about how it can be applied to mining. There are reviews of this standard, and they're positive reviews. But as I said, we've got log normal distribution, like, as you can see in the curve down the bottom right-hand corner. So, it's very important that we just don't take one sample. We take enough samples where we can do good statistical analysis. So I just now want to hand over to our speakers. So Scott Secord, he's a provincial mining specialist with the Ministry of Labour, Immigration, Training and Skills Development. And I've got to know Scott pretty well because Scott, with Kyle, co-chairs the MLR subcommittee on ventilation and hygiene, and both Scott and Carl have done a fabulous job keeping us together. And the Airborne Hazard Management Program has kind of come about, through consultation through this subcommittee. Brent Rubeli, he co-chairs MDEC, but it's changed names now, and I can't remember what it's called now. But he chairs MDEC, and he's also runs the laboratory at CANMET, and he's going to be talking about engine certification. I met Ralph again recently at the mining conference, and Ralph asked if he could present again, so we're very glad the Ralph's presenting. Daniel Rose from Australia is also going to be talking about real-time DPM sampling. And then finally, Judit Nelson. We're very grateful to Judit, who's from Workplace Safety North, and her primary work involves consultation with clients with respect to industrial hygiene related topics. She also teaches ventilation and industrial hygiene to frontline supervisors in the mining industry. Judith specializes in dust control and is passionate in educating workers regarding occupational hazards and controls. And then once we've finished this series, Kimberly's going to introduce everybody to Janice Martell, who's going to help close out the session. So that's it. Now, what I would like to do is just hand the webinar over to Scott. Over to you, Scott. Thank you.
Thank you. I'm just going to share my screen. I don't know if everyone can see this okay. I'm just going to share the screen at large. Okay, can everyone see everything okay?
Perfect.
Thank you. So good afternoon, everybody. My name is Scott Secord. I'm a provincial specialist with the Ministry of Labor, Immigration, Training and Skills Development. And today I'm going to be speaking to you about our new requirement for Airborne Hazard Management Program. So as Kevin mentioned, we've been working on this for quite a long time, and I must extend extreme gratitude to Dr. Kevin Hedges and OHCOW, as well as Brent Rubeli, for their integral support in assisting the ministry in developing this proposed amendment legislation, and as well as developing guidance material to support workplace compliance. So a big round of applause is owed to those two gentlemen as well. This presentation is not intended to replace the Act, and so any version of the regulation that you want to look at, I recommend looking at the Occupational Health and Safety Act and its specific regulations. This presentation does not constitute legal advice, and if you have any questions specifically about the application of the regulations in your workplace, I recommend you contact your legal counsel. And this presentation does not influence ministry inspectors in how they enforce the Occupational Health and Safety Act. They will always enforce the Act based on the circumstances they observed at the time of the inspection in the workplace. That being said, let's get to the fun stuff. So this amendment package that was announced earlier this year to Regulation 854 for mines and mining plants was pretty darn substantive, and we're really excited about bringing this out to everybody. It came out in two phases. The first phase coming into force on July 1st, which was sort of lesser changes, more like streamlining words or updating references, that kind of thing. The more substantive changes really came out in September. And these really include management change, supervisor duty, seismic risk, explosives, airborne hazards, diesel-powered equipment, airflow changes, and elemental carbon OEL changes, ventilation changes for heat and cold stress, as well as reagents, eye wash, and antidotes. And the bulk of today's presentation is going to be focusing on Section 182, which is that new requirement for airborne hazard management programs. So airborne hazard management programs are similar to other programs that you might have seen in the workplace, like such as traffic management or water management or ground control or seismic risk. And they're really designed to be comprehensive programs that set out measures to eliminate or control airborne hazards as identified as part of the risk assessment. So risk assessments are required under sections 5.1, 5.2, and 5.3 of Regulation 854. And the goal of this airborne hazard management program is really to make sure that those hazards that are identified are being evaluated, control measures are being put in place, and it establishes testing, monitoring, and sampling programs for those airborne hazards. The Airborne Hazard Management Program must be developed in consultation with the Joint Health and Safety Committee. and it needs to be reviewed periodically, at least annually or whenever there's significant changes. And it must provide workers with appropriate information to their role in the workplace. So for workers that are exposed to airborne hazards, or for workers that need to understand how airborne hazards are being controlled in their workplace, they need to be provided with information and training on that specifically. Specifically, the Airborne Hazard Management Program must include the measures and procedures required to effectively eliminate or control airborne hazards or potential airborne hazards in their workplace. It needs to identify the person or persons responsible for implementing the program and the training required for those persons that are responsible. It has to detail the sampling and testing frequencies, the locations, strategies, and methodologies for assessing worker exposure, and identifying the contaminant sources. And it must identifies measures and procedures to maintain, monitor, and measure the effectiveness and performance of the control systems. So it's a pretty comprehensive program. And one of the reasons why we want to do this is that we wanted to basically take all the different little pieces that have been existing throughout mines and mining plants, especially things like Regulation 490 for designated substances, or Regulation 833 for control and exposure to biological agents in the workplace. And we wanted to make sure that everything was sort of brought under one umbrella to help streamline and provide a little bit of rigor around managing airborne hazards. So again, like I mentioned, this has a similar approach to water management and traffic management programs, and it really includes the components for the Joint Health and Safety Committee to be involved in the development of the program, as well as identifying the key components for worker training. This will really help to identify and raise awareness of airborne hazards in the workplace, and what it does is effectively addresses one of the major issues that were identified in the 2015 Mining Health and Safety Review, which identified airborne hazards as one of the main risks to workers. So when workplaces are evaluating how they can comply with this new Section 182, they need to really consider the hierarchy controls when they're using the control, when looking at the source, pathway, and receptor model. So what we want to see is how the workplace will be applying specifically the hierarchy controls, which will go into a little bit more detail into the guideline when we review that guideline. We want to make sure that samples are being taken consistently as possible throughout the calendar year on a schedule developed by a competent person trained in occupational hygiene and also in consultation with the Joint Health and Safety Committee. And that sampling programs are developed in consultation with that industrial hygiene professional and the Joint Health and Safety Committee as well. So we're really trying to give a lot of teeth here to the committee, as well as making sure the right personnel are involved in establishing the Airborne Hazard Management Program. So everything from assessing airborne hazards in the workplace, to developing the strategies to control those airborne hazards, to maintaining and testing workers for their exposures, all needs to include Joint Health and Safety Committee at every level. In addition to the requirements for airborne hazard management under Section 182, we also have streamlined some other airborne ventilation requirements. So 252 has been updated. And this is basically make sure that applies to all workplaces, both underground and mining plants, that oxygen at the workplace is at least 19.5%, and that workplaces are clear of contaminants after a blast, that we're not recirculating contaminated air. Any air that's provided is independent of air supplied to a drill or machine, and it has to be initiated prior to workers entering into a workplace. Additionally, Section 254 has been added, which requires both mines and mining plants to develop and maintain written procedures to manage hazards related to heat stress and cold stress in the workplace. Some other lesser amendments but changes to the hygiene protocols include Section 282, which basically aligns the mining regulations with the industrial regulations, and basically establishes that mines and mining plants need to make sure they have eye wash facilities, emergency showers, and antidotes appropriate for where a worker could be exposed to a biological hazard chemical agent in the workplace. And so what we always recommend doing is having workplaces really carefully review their SDSs and any other chemicals they have in their workplaces to make sure that they have the appropriate facilities in place to manage a potential worker exposure. Section 265 had originally set out the requirements for respirators where compressed air has been used. What we did is we actually sort of removed that aspect from 854 and left it alone in 833, and this allows a little bit less confusion around the safe use of respirators in the workplaces. and as we updated sections 268 to 270 on some lesser requirements related to surveying of potentially hazardous reagents in mining plants and making sure that information is clearly presented. So those are some of the big changes. One of the other big things we have done, and with Kevin's help, we actually developed a comprehensive guideline to support workplaces understanding their compliance to the Airborne Hazard Management Program. So if everyone can go to ontario.ca, and I think, Kevin, I think I saw you provided a link for this, and it's also going to be in this presentation as well in your minute package. Or if you just go to the old Google machine and type it in and say Airborne Hazard Management Program, you'll likely land at this page first. And this is the guideline that we have developed from the ministry level to help workplaces understand their obligations and compliance factors with this new section 182. So it kind of goes through the objectives of the guideline, some of the legal requirements that workplaces need to consider, some of the background on why we want to manage airborne hazard, the type of airborne hazard we want to manage, the types of work that's being done that could generate airborne hazards, some of the key elements that need to be included in the Airborne Hazard Management Program, some of the types of measures you want to control airborne hazards, especially when we look at the source, pathway, and receptor model, and different ways to apply the hierarchy of controls on the source, pathway, and receptor model. We go into some information on establishing sampling, testing, and monitoring strategies, techniques, and the like. And then we also go into how to implement a program effectively and how the responsibilities of people who are implementing the program the information they need to have to implement it. We identify some key areas that are of training for both people who are implementing the program as well as the people who are at the workplace who may be exposed to airborne hazards. We take a look at how the Joint Health and Safety Committee needs to be involved in the implementation and development of the Airborne Hazard Management Program. And we include sections on how and when you might want to review the program, the types of things that may trigger a program review. And so we recommend that everyone have a deep dive through this, take a quick read. We're really proud of this guideline. We really think it will help workplaces understand how to achieve compliance with the Airborne Hazard Management Program. We're pretty confident the Airborne Hazard Management Program is going to be an excellent tool to ensure workplaces are identifying airborne hazards and implementing the best controls possible to protect workers' health. So, any questions thus far?
We have a bit of time, actually. You're fabulous timekeeping there, Scott. So maybe we could just throw it out. Maybe if anybody has a couple of one or a question or even two questions, maybe just try and slip it in now. But we will have questions at the end.
Thank you.
I don't see anything in the chat. And if anybody wants to ask a question, maybe you can show yourself and ask the question in person. Okay, looks like we'll leave the questions to the end. Thanks so much, Scott.
Thank you very much.
Wonderful presentation. Thank you. Okay, now we do here. How does the new regulation address scalability for small versus large operations who may have challenges assessing things like a registered occupational hygienist or a certified industrial hygienist? So that for the small versus larger operations, if you're a small operation.
Yeah. That's a great question. So one thing that I think needs to be clear is that the Occupational Health and Safety Act and its regulations apply to an organization regardless of their size. And so the expectation of this regulation and compliance to it is the same whether you're a small exploration site or a ginormous underground multi-level mine. I believe Judit Nelson will be presenting some of that information later, but there's wonderful health and safety association partners like as IHSA for the surface mining sector or Workplace Safety North for the underground and mining sector. And so they have supports and processes through them, as well as we have lots of resource and information available on things that workplaces, especially smaller workplaces, can do to ensure compliance and achieve success in the Airborne Hazard Management Program.
Great, thanks, Scott. So we might go over to Brent now. So Brent, I've known Brent for quite a few years, and it's been a pleasure kind of presenting at the MDEC conference, and I learned so much from the conferences, and there's a wealth of information on the website that are provided in my presentation. But and Brent actually, he does, I believe, run the testing laboratory at CANMET. He might just give us a quick update on the last MDEC conference, and also his background with CANMET. Over to you, Brent. Thanks so much.
Sure thing. Thank you very much, Kevin. Again, good afternoon, everyone, and thank you for joining us today for this webinar. And thanks again to Kevin and his team for putting together the webinar, making sure we had a good representation of different people in different industries with different concerns. I think it's a great opportunity for everyone to learn and share. So I'm going to just a quick update. I'm going to give a fairly general presentation today on how the overall everything sort of pieces together for underground mining, different strategies and approaches, how certification links into this by sort of a general overview. Again, if you go to the MDEC conference website, which is now called the Mining Vehicle Powertrain Conference, you'll find links to some excellent papers we had this year in early October on the Airborne Hazard Management Program, and also other topics related to diesel engine emissions control, and also new topics regarding electric vehicles and other powertrains. That's one way of getting rid of diesel. So if everyone can see my presentation, I'll just get started. So for those of you who don't know us, CANMET Mining, we're a division in Natural Resources Canada. We have about 150 employees in Ottawa, Sudbury, and Val-d'Or. And we're a research organization, the research wing of Natural Resources Canada. And we are developing solutions to environmental challenges, trying to improve industry competitiveness, and most importantly, trying to improve the health and safety of mine workers. We've been doing this work for some time now, and we've been running our conference for about 25 years. So there's lots of good information on that website. So why are diesels underground? Well, because they're economical, flexible, powerful. They have a very fast torque response. However, there is a health concern with the emissions, diesel emissions, and they're also a significant heat source. As mines get deeper and deeper, the heat source is now becoming more of an importance as well. Sometimes the amount of ventilation required to bring heat levels to a reasonable level is more than enough for diesel emissions. So you can have a crossover point in terms of ventilation, but I'll talk a little bit about that later. Underground mining in Canada, around 10,000 tons per day hosted to the surface. Canadian mines are heavily mechanized, multi-level ventilation networks, and in general, diesel is the largest ventilation stress factor. Although, as I mentioned, we're seeing heat coming into that as well. And diesel is everywhere. It's used for haulage, drilling, maintenance, personnel transportation, supervision, everything. But there are health concerns. So diesel emissions are made up of the traditional gaseous emissions, NO, NO2, nitric oxide, nitrogen dioxide, sulfur dioxide, carbon monoxide, carbon dioxide, and water vapor. There's also in the gaseous form and vapor form, we also have aldehydes, other hydrocarbons, including polycyclic aromatic hydrocarbons and nitro-PAHs as well. Those are the unregulated ones, not covered under current regulation, but we're doing research to look at them and are considering including them in future versions of regulation. So there's also diesel particulate matter, and I've shown, most of you have seen this drawing before. This shows the solid core of elemental carbon surrounded by organic fraction, the vapor phase hydrocarbons, and then you have sulfates and adsorbed hydrocarbons sort of stuck to the surface. So diesel particulate it's hard to identify it simply as elemental carbon because it's a mixture of many different compounds all adhered together. There's even metals and ashes sometimes in diesel particulate matter. So when you're measuring it as an elemental carbon, it's always important to keep in the back of your mind that it's much more than just that. In fact, it's such a soup of different compounds that it's very difficult sometimes to regulate it and find occupational exposure data. However, some people have tried. The Environmental Protection Agency has identified that DPM is a hazard to humans. The same with the CDC and the National Institute for Occupational Safety and Health. They've identified it as a potential human carcinogen, and the World Health Organization classifies diesel exhaust as a grade 1 classification, which is a definite link to cancer. So I think that there's no longer any doubt that DPM it causes cancer, and exposure to DPM could also have serious cardiovascular consequences. So this is nothing new. I apologize to Judith in advance for this slide, but I wanted to just highlight that diesel particulate matter is still a concern, because even though your body and nose and throat are capable of reducing some particulates, they are not capable of reducing all particulates. In particular, particulate sizes between sort of lower than 2.5 micrometers end up in the lungs, being deposited in the bronchioles and alveoli, and particles less than 0.1 micrometers get into all areas of the lung and can also get through into the blood and diffuse into body tissues. And what we have found in our research is that diesel particulate matter particle sizes are getting smaller and smaller. So this problem is not getting better, it's getting worse as the particle sizes get smaller and smaller. So those are the major health effects of diesel exhaust. So it doesn't matter whether we're talking about solids, gases, or vapors. Almost every component of diesel exhaust interacts with our bodies at the level of the bloodstream and the tissues. So what can we do? Well, the first step is to develop a toolbox of technologies that can be used to try to reduce diesel exposure in underground mining. The first step is clean fuel, and to some extent this is already done. It's rare to find any diesel fuel in Canada that's more than 15 ppm sulfur. The second step is to make sure that we have the most modern engines and technologies available underground. This includes, the best way to do this is through engine certification. I'll address that a little bit later. Once you have those engines underground, you have to make sure they're maintained properly. Engines that can't be replaced with new technology should receive after-treatment technology or retrofit emission controls, and Ralph will talk about that a bit later. And then finally, there's some new advancements recently in biodiesel and renewable diesel fuels. These fuel technologies can help reduce diesel particulate matter, but there are some caveats. So I'll just talk a bit briefly about certification. You may be familiar with the Canadian Environmental Protection Act, which has adopted the US EPA regulations for off-highway engine emissions. So most engines coming into Canada or imported into Canada have to meet a minimum standard in order to be imported in the country. But for underground mining, there's an additional layer of testing required. This is the CSA M424.2 standard, which is for mobile equipment used underground. And so this standard requires us to characterize engine emissions on a dynamometer. We determine ventilation volumes required to dilute those exhaust gases to safe levels. We have on our website that you see below, diesel.nrcan.gc.ca. If you go to that website, you can see a list of engines that have been certified and approved against the standard, and you can also see the ventilation rate that is prescribed for each engine. So this is a very important tool to be using for underground applications, because you can select engines that are cleaner based on your perusal of the list. And you can also make sure the engines that you're purchasing for use underground are certified and approved for underground use. So it's used in many provincial regulations, including Ontario now. But even if it's not referenced in the regulation, you can still use it to select cleaner engines. A quick review of the list can tell you if you're looking for a 300 horsepower engine and one has a lower ventilation rate, then that means it's a cleaner engine. So it's a tool for everyone. Secondly, exhaust treatment or exhaust after treatment is an important way of reducing diesel emissions. There's sort of three main technologies: oxidation catalytic converters, which can reduce some species of gaseous and a little bit of DPM. Then particulate filters, which are designed to reduce 80% to 90% of diesel particulate matter. And then selective catalytic reduction, which reduces about 70% of NOx. So if you combine them all together, you can get the EPA Tier 4 level regulation for engines. I think that's where we're at now in terms of emissions control. But these devices can be retrofitted to existing engines as well. I think Ralph will talk a little bit about that briefly, but I've shown a couple of pictures of the results. So we did some trials underground where we looked at diesel particulate filters, and you can see the before and after pictures are pretty dramatic. So that we know the technology works well. We just have to get it implemented underground. So finally, in terms of your toolbox for technologies, biodiesel and renewable diesel fuel can be used to reduce diesel particulate matter emissions. And they're from non-petroleum based esters, usually from vegetable or animal sources. Some of the biodiesels are oxygenated fuels. And if they're oxygenated fuels, then that can cause NO2 to increase. So that's kind of a bit of not a great story for underground mining, but we've been seeing that renewable diesel fuels, which are not oxygenated, they're hydrotreated, they have less potential to form NO2. So the industry looked at biodiesels maybe 10, 15 years ago, and the mining industry kind of turned away from them a little bit because of the potential for NO2 increases. But now we're seeing the industry turning back towards renewable diesel because the process has changed and there's less potential for NO2. So we should have some more information for you at the conference next year. Also, once you have all these technologies in place, you have to make sure that you're maintaining them correctly. So emissions-based maintenance is critical. This is something that's referenced in the legislation that Scott spoke about, but it actually does work. If you have a very effective and well-planned diesel emissions-based maintenance program, you can see major reductions in carbon monoxide and DPM just by making sure that the engine is in a good state of tune. And of course, it's really important to make sure that the emissions control systems are also properly maintained and serviced. It's no good having a diesel particulate filter installed if it cracks and there's a big hole. So being able to monitor the performance of these devices as you install them underground is also critical. We need to operate a sampling and monitoring program, both for tailpipe emissions and also for personal sampling. And ventilation. So ventilation controls, it's important to control the emissions at the source and maintain good ventilation, but it's costly. If you can reduce the emissions at the source and put less demand on ventilation system, then I think you're coming a bit ahead in terms of costs, because ventilation is so expensive, especially for hot and deep mines. Lastly, don't forget the technology transfer and training side of the equation. The employees need to be aware of the risks and know how to minimize exposure. And this is where forums like the Mining Vehicle Powertrain Conference are so important, because it allows us to all get together once a year, share our knowledge, share our success stories, share challenges, and try to advance the industry. So I guess in closing, I'd like to say that the best way to manage diesel emissions underground is with an integrated approach. So make sure you're investing in the latest technology, modern engines, emission cabs, emission control technologies. Perform regular emissions-based vehicle maintenance. Always be measuring and monitoring to make sure you're achieving what you think you are. And then stick to the ventilation rates. If you have certified ventilation rates for CSA-approved engines, use them. They've been tested and they're science-based. And then finally, make sure your employees are aware of the hazards, can identify them and know what to do. And then share with the rest of the industry and community your successes and challenges, and we can all advance together. I think that's all I have for today.
Thanks so much, Brent. So just for everybody's knowledge benefits, Brent actually presents regularly to the MLRC subcommittee, the ventilation and hygiene, at the invitation of Scott and Kyle, and I know they greatly value your knowledge, Brent, and it's been fabulous for you to kind of to chime in with that subcommittee as well. And thanks so much for sharing your time with us. We might we are still a little bit ahead of time, and if anybody has a pressing question, I did have a quick question, but if anybody else, and I might ask mine before I open it up. This technology, the diesel particulate filters, and and maybe after you present, Ralph, you might want to add to this, and the engine certification process from CANMET. Can that be transferred to diesels? Could that be used for diesels in construction, say, rather than just underground?
We have done that. So we occasionally get inquiries from construction companies that are doing tunneling, for example. I think we did a project recently for the city of Ottawa where they were looking at the tunneling construction for the LRT system in Ottawa. And they're looking at, because even though the trains are electric, the construction equipment is still diesel. So I think we have situations sometimes where they'll end up with exceedances of certain pollutants, and they often don't quite know what air they should be providing to the construction equipment that's being used in the tunnels. And the ventilation rates provided by CSA certification to M424, but also even the 100 CFM per horsepower rule is very valuable. In the mining industry, we're very conscious of ventilating to a required number first, and then checking and verifying that with ambient air quality data. So we start with a target of say 100 CFM or whatever ventilation rate is required for the certified engine, and then we ensure we're getting that by looking at the ambient air quality data. In the construction industry, they often don't have a target to ventilate to first, so they're often ventilating only when they see exceedances on the air quality monitors. So they're kind of doing it sort of after the fact. So oftentimes when we tell them that there's ventilation rates published for certain engines, and even then there's the 100 rule as a sort of good starting point, that helps them out a lot. So we see that in the construction industry. We also see that in warehouses. This time of year, actually, we often get a lot of phone calls because warehouses are starting to shut their doors and close down ventilation fans because of the ambient temperature outside, and that often drives emissions up. So I get 3 or 4 calls a year from warehouse companies looking for some guidelines and advice, not necessarily mining related, but for tunneling construction and also warehouse use.
That's fabulous feedback. Thanks for that, Brent. So I can't see any other questions or any hands up in the with all the participants. We might now go to Ralph Deayton from Mammoth. So, we're also looking at trying to share solutions, and diesel particulate filters have been used for, they've been increasing their use. And that's what Ralph's going to talk about, the diesel particulate filters use and as a solution to reduce its source, reduce diesel emissions at source. So over to you.
There is one question,
okay,
in case you didn't get it.
It just came through. Okay, it's from Megan. So I guess I guess it might be to Brent, but yeah, maybe to Brent. Do you have any knowledge to what extent these diesel particulate controls are known and utilized by the mining industry in Canada? Cost may be a limiting factor, I would guess. Did you want to take that one on, Brent?
Yeah, sure. I can say that diesel particulate filter technology is well known in the industry. We've been talking about it for probably 25 years. In fact, CANMET Mining was participated in the development of the very first diesel particulate filter in the early 1980s. So they're well known, but I think they're not well distributed across the industry. Cost is a factor, but also regulations or mining regulations have often not provided an incentive for the reduction of emission control technologies. For example, when Ontario had the 100 rule, 100 CFM per brake horsepower rule, there was no, you could put a DPF on the engine, but you would still have to use the 100 CFM per brake horsepower ventilation rate rule. So there was no incentive to do it. And what we're seeing now is, and I realize that seems a strange answer, but in terms of looking at ambient air quality controls, they're a big advantage, but in terms of purchasing and cost, it's hard to justify it. We're seeing different provinces now moving towards sort of ventilation rate based regulation, that will incentivize the use of diesel particulate filters. And I think we'll see air quality improve as a result. Not only that, in terms of modern engines that you're buying today, the vast majority of engines that you're buying brand new today come with a diesel particulate filter. So they're getting underground anyway. Now we're looking at retrofitting some of the older engines that don't have it.
Thanks, Brent. Just to add to that, I remember the person that chaired the subcommittee before Scott and Kyle, Glenn Staskus, gave a presentation at MDEC many years ago, and he showed a pie graph, and in that time, diesel particulate filters weren't commonly used across mining, and then over with, I guess, through MDEC, just raising the awareness, the importance of DPFs in mining. I think there's a lot more usage now than there was then. Would that be a fair comment, Brent?
Yes, I would agree.
Okay, great. Okay, thanks. So over to you, Ralph. Thanks, Brent.
Very good. You're seeing my screen okay?
Yes.
Yep, perfect. Well, thank you very much, Kevin, and also to Brent for your presentation. Certainly appreciate the opportunity to be here today. My name is Ralph Deayton. I'm with Mammoth Equipment and Exhaust. We're based out of Winnipeg, but we have locations here in Canada in both Sudbury and in Edmonton primarily. And just wanted to share a little on diesel particulate filters and how they are used in enclosed environments. So the obvious application here being underground mining, but as Brent just alluded, tunneling and warehousing, other enclosed environments they would also be applicable for. Just as to who Mammoth is, the company actually started in Australia in the 70s and was manufacturing exhaust components for mobile mining equipment. And I guess as Australia reduced the worker exposure limits for diesel particulates in the mid-2000s, there was obviously a huge demand for after treatment systems to meet these new requirements as being one of the options for lowering worker exposure. And the diesel particulate filter was developed for mobile mining equipment by Mammoth. Here in North America, this became we opened a location here in 2015 to support a project that was being carried out at the Musselwhite mine in Northern Ontario. So just moving ahead, what is a diesel particulate filter? So as we know, when a diesel engine is running, the unburnt fuel, while a diesel engine is a very effective way of powering a vehicle, we do know that any unburnt fuel creates smoke or diesel particulates, and that obviously reinforces the need for good engine maintenance, so keeping air filters clean and regular monitoring of valves, seals, rings, injectors, all that kind of thing. But as we've discussed, one of the best ways to eliminate or reduce diesel particulates in an enclosed environment is through a filtration system, and that's what a diesel particulate filter is. Many times what you'll see is they are in three sections, where you've got a catalyst or a DOC, diesel oxidation catalyst, then a soot filter, and then an outlet. It's been essential, or has been a requirement of every diesel engine underground for many years, to have a catalyst or a purifier or a scrubber, PTX as they're sometimes known, for the reduction of carbon monoxide. But what we're now doing is adding that to a soot filter. And so you see the two different components. One is more of a honeycomb, one is more the filter, the square block design. And so what do we see as a result of these filters? So there's many different pollutants coming out of the engine. CO, as we've already mentioned, we typically see an 85, can see as high as 90% reduction, depending on the heat, the temperature coming from the engine. We also see obviously the diesel particulates, they pass through the catalyst and they are reduced in the soot filter. And then one other consideration that's now being monitored at the tailpipe is NO2. And I believe the new Regulation 854 has set a tailpipe limit of 60 parts per million, 60 ppm for NO2 at the tailpipe. And so NO2 is a key component for the success of a DPF, because as we would well know, soot or diesel particulates, they're heavy, they're dense, they're oily, and if you pass them through a filter, whatever medium that may be, it would plug that filter quickly. And what has been discovered is at a certain temperature, those diesel particulates, that soot, can be baked or ignited and reduced down to ash, which is obviously a very low density. And so you can effectively fill these soot filters, load them, and then they can be self-cleaned when an engine reaches a certain temperature. And the success of that does require NO2 gas. However, we do often, and this has been proven in many field tests, and we'll see some results in some of the next slides, we can see an NO2 reduction from the inlet to the outlet of a DPF. So what happens inside a filter? Just wanted to cover that off. As I mentioned, the soot, the DPM is coming out of the engine as unburnt fuel, so especially seen when the on startup or when the engine is running at idle or cold. We see heavy soot loading of these filters, and the exhaust will travel through from the engine, reaches the filter. The filter is made up of a number of adjacent tubes or channels, and every inlet channel is capped or blocked off at the outlet end, and the outlet channels that are adjacent are capped off at the inlet end, and that forces the exhaust flow to pass through the side walls of those channels, and that's where the reduction in DPM occurs. Many times this reduction on many different types of DPFs will be in the 95 to 98% reduction range. And it's interesting to note that these filters are not unique to mining equipment. We see them commonly used in construction, highway, many different applications where diesel vehicles are being used today. And so, as I mentioned, the heavy, dense, oily particulates will fill these channels. And then when the engine operating temperature reaches a certain point, many times it's in the 320 Celsius or 600 Fahrenheit range, and that soot will ignite and bake down into an ash, which is a low density material, and effectively the filter will self-clean, and that allows the vehicle to run for many, many hours without needing any servicing to that filter. So what can often be seen in a typical application with a underground mining haul truck would be the vehicle could unload at the crusher, would then roll down the ramp to be reloaded. During that time, the engine would be under very low or little load, and then obviously the vehicle could potentially idle while it's waiting to be loaded. And during that time, this filter would accumulate soot and would begin to load or plug up, essentially. And then when the vehicle was now loaded with rock, with ore, and turns around, heads up the ramp, the engine's operating under heavy load, and the temperatures reach such a point at which the soot will ignite and bake down and reduce down to ash. And that obviously that cycle can then happen over and over again. through the vehicle's work cycle. But one thing to point out is that with a DPF filter, whether the vehicle is idle, whether it's operating under low load, or whether it's operating under full power, the filtration capacity of this DPF, its ability to reduce DPM, is consistent in that 90 to 98% range. Here's some examples of results that we have seen at different mine sites, but you can see pre and post with a smoke dot test. You can see before the DPF and after the DPF, significant reduction, barely visible here on the post DPF test, and then also you can see the reductions in CO and NO2, so 202 ppm down to 15 and 30 down to 15. Again, likewise here. I realize these are field tests, these are not laboratory tests, but most mines would be completing these field tests every PM or monthly, depending on how their processes are set up. DPFs have been developed, as I mentioned, for all applications of diesel engines, so all makes and model, and generally they can be designed to fit in replacement to the factory supplied muffler with minimal modification to the vehicle. A variety of different applications here, so you can see there's many different configurations, some vertical, some horizontal, and effective means of reducing DPM in an underground environment. I think that's all I had. Kevin, happy for any questions that there may be.
Fabulous. Thanks so much, Ralph. And this is such important information on reducing exposure to diesel particulate. Before I kind of just throw it out to questions, I had a couple of thoughts myself. The first one, just for the people listening, are there any traps, like when selecting a diesel oxidation catalyst? We know that some diesel oxidation catalysts can increase the level of nitrogen dioxide. So firstly, I'm just wondering if you'd comment on that. And secondly, is there a list of authorized diesel oxidation catalysts that mines can go to so that they know they're getting something that isn't going to increase the nitrogen dioxide?
That's both very good points, Kevin. And so there'll be many different things that we would look at as a manufacturer before we would be putting a DPF. And with a DPF, obviously you would get a diesel oxidation catalyst or a DOC. Some of the main things we'd be looking at would be the engine work cycle, so how the vehicle is used, the size of the vehicle, the usage of the vehicle, the utilization. Often we'll put some kind of data logging device on the machine to get some data before we make a recommendation. And obviously once we have an idea of what the temperature we can see from that engine, if it's a high work cycle or a low work cycle, we'll then make a recommendation as to which DOC to go with. Effectively, I often use the analogy to adding salt to water to lower the freezing point. NO2 creates those conditions at which the regeneration of the soot to ash can happen. But if you don't get that matched to the engine correctly, you can create very high levels of NO2, which is obviously undesirable. I don't know if that helps any.
That's great, thanks. So we're kind of on 2 o'clock now, and we're right on time. And I just want to welcome Daniel Rose. And, we're very lucky because Daniel's actually, he's on the webinar from Australia. And I can't even imagine what time it is there now. So Daniel's with PINSSAR, and I spoke to Daniel at the recent MDEC conference, and it just kind of piqued my interest to hear about the real-time monitoring for diesel particulate matter underground to kind of show whether or not these filters are working or not. So this is more an ambient test, so it's not personal exposure monitoring. And just be very careful that really the only way that you can compare levels of exposure is from personal exposure monitoring. So I just want to provide that caveat up front. And also Judith's probably going to talk a bit more about that after Daniel. So over to you, Daniel. Thank you so much for joining us.
Thank you, Kevin. Just want to check my microphone's working well.
Yeah, we can hear you loud and clear. Excellent.
Thank you. Thank you for the invitation, Kevin. Greatly appreciated. Yes, I'm coming to you from the future Saturday morning, but definitely when I received this invitation, I had no hesitation. So I will share my screen and jump straight into it. So the first half of this presentation, I will skip through really quickly. It's just a bit on the background of DPM and PINSSAR itself, and we'll concentrate more on the case studies and how mines use the PINSSAR to help them. So we've all seen this. This is a well-educated audience. We sometimes come across less educated audiences and have to run through the size of DPM being sitting in that 800 nanometer range. And then we also talk about comparing with the larger particles and how the DPM can be absorbed into the bloodstream. So I think it was Kevin that started off, or maybe Scott with, sorry, it was Brent who was showing the slide about how it can penetrate through the lungs, and that's why it's been known to not only cause lung cancer, but certainly brain cancers and other types of cancers, because it is absorbed into the bloodstream. We also usually talk about the 2012 declaration from the World Health Organization. And this most of you probably will have seen as well. This is taken from the internet. This chart shows how DPM behaves, and it's not linear. This x-axis, you can see 10,000 nanometers or 10 microns here on the right-hand side, and 1 micron here, and then under 1 micron is stretched out. And what this chart is showing is how DPM behaves. So straight out of the combustion process, where the temperatures are quite high, it produces a lot of very, very small particles around just over the 10 nanometer size. But as things quickly cool down, those particles will look to join together or agglomerate. And so the number or the count comes down very quickly. But what happens is the surface area and the surface mass of those agglomerated particles increase. So the reason we wanted to show this is just to show where the PINSSAR was designed to monitor. It was built specifically for DPM, ground up. So it monitors between the 8 and 800 nanometer zone. But more specifically, the peak accuracy or the focus of the laser on board the monitor looks at that 70 to 370 agglomerated zone, which is what we see in the atmosphere, trying to capture that agglomerated area. And we have seen mines in the past try to use dust monitors to measure DPM. Their theoretical range can come down to around about 300. That's obviously on their extremities of their capabilities. They're designed to measure dust, just like PINSSAR is not designed to measure dust. We're designed to measure DPM. Just a quick look at other methods of measuring DPM. So there's tailpipe testing, which is normally a regulatory requirement around the world. That's usually done in a controlled environment, whether it's a surface workshop or even an underground workshop, and is a great way of determining the health of that particular vehicle. But then that vehicle goes back underground and does a range of different activities and mixes with other vehicles. So that test whilst it's good for each individual vehicle, it's not representative of what's actually happening underground where people can be exposed. It's one piece to that puzzle. The personal monitoring, again, a great technology for what it's designed for, and you're all very well familiar with that. And I guess what would say is that when the sample's handed in at the end of the shift and the hygienist sends it off to the laboratory, depending on where your mine is around the world, it can take 2 weeks up to 6 months. We've heard at one mine to get that result back. And when you get the result back, while it's good for understanding personal exposures, it's difficult to trace back to understand how the controls were working at that particular time. So if there was an exposure, it's difficult to tell, was it in hour number 3 to 5 of that 8-hour or 12-hour shift? And where was that person? It takes a lot of work to go back through work logs to try and understand where that exposure occurred. And then there's the ambient handheld monitors, which are usually used by ventilation officers, and they can be used quite effectively to take a spot check of the ambient air underground. So again, a great tool for what it's designed for, but it's not a continuous tool. So you probably find after a shift or so that filters will start to clog up and possibly batteries will start to go flat. So PINSSAR are not here to replace any of these technologies. They're all great for what they're designed for, and the top two are regulatory requirements. The PINSSAR is not a compliance tool. But these three give you, I guess, point in time, intermittent checks of how the environment underground is going. So this is, you're unable to manage your controls with those types of devices on a regular or continuous basis, and that's where the PINSSAR comes in. That's what it was invented for, was really to provide the mine a practical tool to manage their controls and continue to monitor and verify those controls. It's things like ventilation that we've talked about and DP filters, which Ralph just talked about. And what PINSSAR recommend is that all these technologies, the data from these technologies are used when you have your DPM committee or as part of your long-term airborne hazard management program, those long-term strategies. We recommend that you should be looking at the data from all these devices when making decisions, especially around procurement and investment. So basically, another easy way to say it is that the PINSSAR is just another piece in the puzzle for your monitoring program, and there is no silver bullet, as we all know. And I guess as the majority of the audience will be hygienists on the call, we know it's not one person's responsibility. It's a mine-wide responsibility. So the monitor, the PINSSAR monitor is used by ventilation, but also senior management and superintendents keep an eye on the PINSSAR data as well. So what is the PINSSAR? It's basically two things. One is it's a low maintenance, robust box or monitor that is hung on the wall underground to sample the environmental air in that area. The second part is the data that it produces, which is sent through Ethernet or Wi-Fi onto the mine site SCADA system or onto a PINSSAR dashboard that comes with the system. And that data is very user-friendly and configurable. And I'll show you some information on the dashboard soon. So there it is on the left. Just looks like an electrical cabinet. And on the right there is some shots of the dashboard, which I'll show you a lot closer coming up. It also can be configured to be on your mobile phone, and it can send email alerts or SMS text message alerts as well. We're now on 6 continents, including in Ontario, which is fantastic for a company that's really only been commercialised this product for just over 5 years. So certainly awareness is growing. and certainly the mining companies are embracing the real-time continuous technology. So now I'll slow down a bit over these next few slides. This one is just to more show you an example of the dashboard of the PINSSAR system. This is a tunnel construction project in France, on the French-Italian border. And this is 2 weeks of data that you're looking at now. So the top dashboard is what we call a dynamic view. It's showing every single sample. The unit samples once every 5 minutes. And then this bottom one is the shift average view, which is, I guess, a better correlation to your OELs and a better guideline to your OELs. So in this particular instance, the operation assumed that they would be running in green. They started up their PINSSAR and it was running in the yellow. They stopped for a Christmas break and or had a skeletal staff for the Christmas break, so that dropped from an average of 180 on the previous shift down to 10 micrograms per meter cubed. And when they returned from the Christmas break, the management saw this data. They ordered an investigation. They found the problem. They rectified that problem. And they often running in production, they kept under their OEL of 50, which is the European OEL. So it's a great visual way of seeing how you're performing, how you're trending, and if something needs to change, and the result of that change. Okay, so now I'll go into a much more detailed case study. This is at a coal mine in Australia, and after this, I'll show some hard rock examples as well. But this is more over a sort of a 3-year journey that one of, I guess, the early adopters had with PINSSAR. So the hygienist on site, when this mine purchased in late 2019, did some tests on the surface with the PINSSAR, comparing it with the NIOSH 4050 and also the AirTech, which was available at the time. And the results of that pretty substantial testing was that there wasn't really a linear correlation between the PINSSAR and the AirTech, but there was a correlation between the PINSSAR and the NIOSH 4050, comparing the average results. And what their finding was that rather than looking at every 5-minute sample from the PINSSAR, they were better off looking at the PINSSAR from a bit more of an average perspective, and their example was, i.e., a 1 to 2 hour average. And that's what PINSSAR recommend, but in this instance, it was part of the mine's journey for them to understand that themselves. So phase 2 of their journey was the 2021 longwall move. They had one PINSSAR system, and really there wasn't much of a plan. It was, let's let the PINSSAR run, and after the longwall move, for those that are not familiar with a longwall move, it usually takes about a month of retracting the longwall equipment to the surface and giving it a refurbishment, and then putting it back in the next block, and that's the highest DPM risk of a longwall mine. A longwall's electric, obviously, so production doesn't have those risks, but certainly there's a lot of torque required to pull those longwall chocks out. So it's certainly an area of focus for longwall mines. So yeah, they put it in and just let it run, and then at the end of that sort of month or 6-week period, they got their personal samples back from the NIOSH 4050s, and they returned 23 exceedances. Now, I must point out that's over the BHP OEL of 30, which is probably one of the lowest around the world. But nevertheless, they call them exceedances. The Australian standard is 100, so they're under a third of that, but still that was an exceedance for their company OEL. So we then sort of partnered up and took a look at the data with Broadmeadow. So PINSSAR never see the data unless the mine chooses to share that with us. And we're getting more and more mines asking for a a bit of a look and to make some observations and recommendations. So we took a look at this data. We compared it to those 23 exceedances. We got the shift logs back to understand what was happening. And that retrospective review revealed the majority of exceedances aligned with what the PINSSAR was telling them at the time in real time. So the conclusion was that, okay, let's look at this in our next longwall move. Let's put the PINSSAR, let's look at it actively, and I'll go into a bit more of that decision making soon. But here's some of that comparative data. So you can see this is 18 days of data of the PINSSAR tracking along in through the green and the yellow. And again, this is quite a low OEL of 30. And you can see the days where they recorded the NIOSH exceedances, and obviously the NIOSH sampling isn't occurring on a daily basis, so it's giving you that point in time type measurements that I was talking about earlier. But certainly the PINSSAR data correlated with those exceedances. So then what did we do with the data? We said, well, what if it wasn't a retrospective review? What if we didn't know there was exceedances coming? And what the answer is really you'll be focusing on the trends and trying to keep that as low as reasonably practical. So now we deep dive into one of those days of the 18 days where we don't look at the shift average view, we look into the dynamic view. And again, this was, okay, what if we didn't know about the exceedances? What would we be doing with this data in real time? So this particular day had a shift average of 42 micrograms per meter cube. And you can see throughout this shift, there are spikes that go into the yellow and even the red zone in one instance. So when looking at this data, we knew that alerts could be set to whatever the mine wants. It's very configurable in terms of the alerts it provides. But you didn't want to provide too many alerts because you'll end up with no action. Nor did you want those alerts to be too late, where it's too late to make any actions. So it was a very thorough review of this data, and also before the alerts are even set, you need to understand what actions are available. And in this instance, at this mine, there wasn't too much additional ventilation they could put into these areas, which is common throughout the world in many mines, especially as they're putting in new shafts and waiting for that additional capacity. So yeah, there's engineering controls to move that average down, but there's certainly other controls, and they looked at all sorts of things like shift change outs where they rotate staff, and certainly keeping an eye on the vehicles and what they're doing and the number of vehicles and the maintenance on those vehicles as well. So really what they looked at doing was, what happens, we're not going to be able to stop that original spike from going. That the PINSSAR won't predict the future, but it'll tell us when it's jumped into the next zone. And what we want to do is try and cut the tail off those spikes, and therefore change the course of history essentially, and bring that back down into the green much quicker. So if you do that across all these spikes, you are going to lower that shift average back into the area that you want. Still looking at the same day of data, looked at 1 hour averages to see where you would get the alerts, and in this instance, this would be traveling in the yellow for an hour, and you'd get this alert at 10 a.m. So then they looked at rolling averages, a 1 hour rolling average, and the same alert would be at 10 past 9. So it was deemed that the rolling average was much better to provide them alerts with much sooner. Okay, so into phase 3, or leading into phase 3, the mine had a DPM committee meeting in the February of 22. The decision was to increase the PINSSAR samplings during their next longwall, which was in September. They purchased 2 more monitors. The PINSSAR isn't intrinsically safe, so they made special allowances where they could to change their explosive zone into a non-explosive zone to put the PINSSAR in to monitor. and because it's being coal mine, and methane was certainly a high risk there. And the action was for site to actively view the PINSSAR in real time during that longwall move. They set up a trial TARP with those trigger points based on the previous data review. And the people that were getting the alerts were the district superintendents underground, and they would go and investigate when the trends started to trigger into an alert. So they could go into that to real time. So that was the plan. And here's the result. So like we said, in 2021, with not actively using the PINSSAR, they had 23 exceedances of their OEL. In 2022, when they were actively using the PINSSAR and responding to alerts, that dropped down to 5. So a great achievement by the mine. They certainly put a greater focus on DPM with a number of different things. So they made a number of changes, but certainly the PINSSAR was seen as a significant piece to that puzzle when in those reductions. Okay, so that was that coal mine example. I'll just quickly run through some other hard rock examples. So there's a mine in the USA that used the PINSSAR for underground traffic management. They currently have 15 PINSSARs in strategic locations. This mine has very narrow roadways and a lot of diesel auxiliary equipment and people carriers. So they have some traffic management or rules around how many of those people carriers can go in at any one time, and they monitor the DPM loads at these 15 points on a continuous basis, and they measure that against the OEL in US of 160. There's a mine in South Africa. They've used the PINSSAR in quite a unique way, and it's gaining more interest around the world now. They actually use it to manage their fleet maintenance. So some of the stuff that Brent and Ralph talked about, mines are starting to use the PINSSAR to keep an eye on how that's going and if something needs to be changed on the vehicle. So they put a video camera on it. They previously get a baseline of each particular vehicle. And then during operation, if any of the vehicles show abnormal high reading, they'll go and look at the video footage, they'll identify the vehicle and then radio that operator, and they send it to the surface workshop for inspection and maintenance. So other mines around the world are looking at implementing this, but with an RFID tag system, so it becomes a lot more automated. There's a mine in Ecuador that's using the PINSSAR to manage their DPM control. So a bit like the coal mine example. So there's no OEL in Ecuador. So the mine is using the Ontario OEL as their company OEL. It's a Canadian-owned mine. Currently, they have 7 PINSSARs, each at specific levels, and the data goes straight to the control room, or dispatch as they call it. And they're viewing it in real time, and if the level is breached, they radio down to that particular level, the superintendent on that level, and they go and investigate and rectify, and they need to radio back to control room to tell them what they've done to rectify it. This is the last slide. So we've also got a mine in Mongolia that's using PINSSAR monitor to assist with OEL compliance. So I'll be clear, we certainly don't say that the PINSSAR monitor is used for compliance, but in some instances like this mine, which is very remote, it takes them 6 months to get a gravimetric result, and there's a lot of transport involved in those samples coming out of the mine to the laboratory. So they're looking at the PINSSAR to be able to provide them with a better guideline or a quicker guideline to how they're performing against their company OEL. So they currently have 9 monitors in what they call mine air quality stations, which also consist of dust monitors and velocity meters and things like that. And they have future plans to integrate with VentSim. So the PINSSAR system is the only system in the world that can talk with simulations and ventilation on demand systems such as VentSim and VUMA. The Queensland coal mines, there's quite a few of them that have now had to change or adapt to a new OEL. So similar to Ontario, a new OEL was legislated through Parliament. It was introduced in February this year with a 1-year transition. So from February 24 on, the inspectorate will be enforcing it, and that's half the Australian OEL. So they're a leading region in terms of Australia, and the mines are using continuous monitoring as helping them transition to that OEL. But as Kevin pointed out early on, the OEL is really not a defining line between safe and not safe, and ALARP is certainly wherever we go, and whenever we're talking with inspectorates and mines, they're talking about getting as low as possible, which is the right way to be thinking about contaminants. And just finally, the tunneling projects, they are using the PINSSAR more as a compliance tool, because the British standards actually nominate continuous real-time monitoring for DPM. Okay, thank you for that. Hopefully I got that done in time.
Thanks so much, Daniel. It's amazing work that you guys have done, and to share that knowledge with us, we're very grateful. And if you're getting up, what time is it there?
5:26, so I went well over. I'm sorry about that.
Well, what we'll do is we'll just, I wanted you to kind of share it to the end, and we've had questions throughout, so we might just go straight to Judith's presentation.
Sure.
And thanks so much again. Really appreciate it.
Yep, thank you, Kevin.
Over to you, Judith.
Just 1 second. Can you see my slides?
Yes, we can.
Oh, thank you. Thank you, because I lost you on the screen. First and most important, thank you for inviting me. I'm always excited if I could reach out to other people and spread the word of occupational hygiene. So my name is Judit Nelson, and I'm working for Workplace Safety North. Private Workplace Safety North is a safety association. We're focusing on prevention of health and safety related injuries, illnesses, and of course occupational hygiene falls on there. So here's some links if you want to look at our websites. So I'm going to go quick a little bit so we could catch up with the time. Okay, so my question is this: when I hear all the webinars and communications coming out, are we only really talking about diesel particulate only? When we look at Airborne Hazard Management Program, we're paying lots of focus on diesel particulate, of course, because we lower the occupational exposure limit for diesel. However, there is many other elements are in an airborne environment of the worker, where, for example, working underground, you could almost say that it's a confined area, and all the contaminations are increased as they're working, not like working in a surface. So some of those contaminations, for example, gas, vapors, aerosols, dust and mist and fumes. So I'm going to try to focus on not as much as on diesel, because we did talk lots about that, but how about other contamination? And these contaminations are generated through a variety of activities, surface and underground mines, for example, crushing areas, welding, mixing, even just as simple as loading and hauling the ore to the dump sites. So this picture, it's a good example. I took these pictures last year. This is actually quarry, and I don't see it, but actually there is workers behind this dust wall. Some of the common exposures of mining is primary. We are really focusing on silica dust. In Ontario, we do have some pretty high silica levels in rock composition. Respirable dust, that's something which people, we could almost call it, all the dust particulates is a nuisance dust, because really workers are really get bothered by, feeling the dust around them, seeing them, and lots of time even digesting them if there's dust is concentrations are so high in the work areas. So silica respirable dust, we look at calcium oxide, for example, when shotcreting or cement mixing activities are happening, and which is very common task to do underground for cable bolting or building fixed stations, pads, or use it as a ground support. When we look at metal, fume exposure, we look at different types of metals. For example, we primarily look at manganese and iron oxide with mild steel welding, but we do encounter lots of time, and Kevin, I think it was a great lead into this presentation, the potential exposure to lead. It's amazing where we could find lead. And lead is one of those things that we do see mechanics and welders exposed to it, especially because in an underground environment, many of the mobile equipment has a base coat of paint, which is a light gray color usually. And that base coat underneath the real color of the equipment is actually contains lead. It's widely used, very good against corrosion. And I do see some potential lead exposure hazards on mechanics and welders when they working with those equipments. You also have to look at potential gas exposures. So in an underground, we're mostly focusing on CO and NO2. Usually those gases are generated during blast, but as we mentioned, that when a diesel vehicle is operating, combustion also generate those types of gases. Methane, for example, or ammonia is another gas we would have to look at. When we look at Airborne Hazard Management Program, I think we also have to think not just what actually people breathing in, but potentially, you know, what actually other route of entry. So just to give you an example, especially, you know, shops in an underground environment, lots of times, you know, personal hygiene can be improved, if I could say it nice. Lots of times workers are actually eating on the job. So, for example, if their hands are contaminated with lead, then we see that they actually end up ingesting lead into their body. So we also have to address potential other routes of entries when we're looking at Airborne Hazard Management Program. This picture in a circle actually is dust particulates. I could not see it with my own eyes, but one of my favorite tool underground to use is actually a camera, which is strong flash, and the particulates actually gets picked up by the flash, but not with the human eyes. So it's a kind of an eye opener to see that all those dust particulates in a work environment. So with the Airborne Hazard Management Program, ideally you want to have an occupational exposure monitoring program under that umbrella, where you're trying to measure and assess the worker exposure. And eventually, when you collected enough data from those certain exposure work groups, you're going to be able to do a statistical analysis and able to develop a worker exposure profile. So you're going to be able to see what would be majority of the workers would be exposed to certain levels of concentrations of chemicals. So when you're looking at occupational exposure monitoring program, we must understand a few elements. For example, the level of exposure. So that's usually come by measurements, so quantified measurements of the agents. However, not always have to be. Sometimes we could do some qualitative assessment, even just as by looking at, you know, the workplace environment. Not always I have to go there and measure it. If I see, let's say I'm going into a shotcreting zone and I see lots of particulates in the air, I do know the hazard is to exposed to dust is really high. So the level of exposure, we look at it, the duration of exposure. So how long is this worker there? The occupation exposure limits for 8 hours. However, we do have majority of the mines, our workers are not working 8 hours. They are 10.5, 10 or 12-hour shifts. So it's important to understand, you know, the worker who's working a 12 hours is going to be exposed more to the same element if it would be working in an 8 hours. So we have to look at that. Identification of the exposed workers. So we try to do group the workers into called a similar exposure work group, and I will touch base with it in a separate slide. But we want to make sure that we try identify the workers who are has the potential risk to expose to different chemical agents in this case. So the goals, what we're trying to do with occupational exposure monitoring program to eliminate or reduce the hazard. Number one, the end of the day, we want the workers to go home safe and healthy. Assist with risk assessment. You could use the data to evaluate, you know, even just as simple as policies and procedures when you do your risk assessment for them. Improve selection of personal protective equipment. You want to make sure you verify that, for example, if you providing respirators, the respirator has enough protection factor that to protect the workers against the agent. And of course, you also like to do some monitoring before and after you implementing a controls. And as mentioned that, for example, if you install a diesel particulate filter, ideally you want to have some pre-test done on the equipment. And then after you install the filter, you would want to have a follow-up test and see that how effective is that filter. Did it even make a difference? I do see that lots of times when organizations install beautiful expensive controls like water spray system, dust collecting systems. And then we realize that when we're doing personal monitoring, the controls are not effective to reduce the exposure levels. So it is always important to evaluate whether we actually made a difference. And this picture is actually in an open crusher area. This is a cabin filter, was the operator when I opened it up. So you could imagine that what's inside the cabin too. But again, when we're looking at Airborne hazard management program, we also have to include, you know, our controls, our maintenance policies on that. And that's, for example, in this case, you could clearly see that they installed a filter in cab of operator cab, but they were absolutely not maintaining this filter. So this is just an example of an occupational exposure monitoring plans. They come in many different ways. This is something that I use. It's simple. I use an Excel sheet actually to develop that, so that every client of my client has access to Excel sheets. But basically it is that we identify the similar exposure work groups. For in this case, I put an LMAC minor in here. I identify the agent. What are the agents this work group is potentially be exposed to while they're working? And then we have a likelihood of the exposure and the severity level of the chemical agents. And then we, from these two numbers, we derive the decision of the risk. And then from there, we decide whether we have to monitor for that particular agent. So for example, if you look at, let's say, oil mist, when we're looking at an LMAC minor oil mist exposure, we want to monitor. I put in monitoring for the oil mist because the jacklegs and stoppers are commonly used. These are handheld drills, and both of those equipment emit lots of oil mist from the cooling liquid they release. So I do see sometimes exceedance in oil mist exposure. We also look at, for example, silica, because they are using handheld drills and they're breaking rocks. So we want to also evaluate, you know, what are the exposure levels. Now, a number of samples are different here. Really don't look at these numbers. It's just an ideal in here, but you want to base your number of samples, for example, how many people working in an area, how high is the risk, maybe you have previous monitoring results. So that's also drive the decision on how many samples you will be monitoring. So an occupational exposure monitoring plan is basically almost like a risk assessment. You look at your similar exposure work groups. You try to identify all the agents that the worker is going to be exposed to, in this case. And then you're trying to come up with a decision whether you want to monitor that agent or not. And that's all coming from your risk rating here. And then you look at, okay, you decide that, okay, we're going to monitor, for example, silica here. Then we would go back and look at, okay, how many workers are exposed to this? What are the shift lengths? And then from there, you're going to be able to decide how many samples you would want to collect for that same exposure work group. So similar exposure work group is one of the most important elements of occupational exposure monitoring program. You have to be able to identifying the workers that have a same, usually work in the same location. They're doing similar type of jobs, tasks. They use, for example, similar chemicals, and they also use similar equipment. And for example, here, LMAC minor, but another similar exposure group would be like an electrician, or a open cap scoop operator would be another one, or a millwright would be one, because all those tasks, all those workers are doing similar things during their work hours. So here is just a quick example of similar exposure work group. 5 workers working in a lab. They are doing rotating jobs. So that means they are not always doing the same jobs. They go all through the lab and they're doing a sequence of jobs. They use the same chemicals. So an example, pulverized lock. They have some lead oxide, potential lead oxide exposure, calcium fluoride, sodium tetraborate. These are all chemical agents that they are exposed to. So you could put all these elements in your monitoring plan, in your program, to identify it as a potential hazard. And you could drive a decision whether you need to monitor these chemicals or not. And of course, a similar equipment they would use. So that's why this work group would be we would put them on a similar exposure work group. This picture actually taken from a lab technician who's working here. You could see that how loaded is the filter. Even the pump housing, even it had a nice big case on it, was just saturated with dust. Another similar exposure work group, for example, the welders, or millwrights. These are actually real samples I collected a year and a half ago from a large welding group. You could see that, picture says 1,000 words. Inside the filter is a white filter. This is the original killing filter, and these are all metal filters. And the darker, usually the coloration, are usually we see that people using torch and burning steel, but all these workers were cutting mild steel during the workday. So could just imagine that what's inside the people's lung when they're doing some hot work activities. So again, we try to group them together because they're doing similar tasks, similar location, using chemicals. I also throw some, just want to kind of put a little push to WSN. On the website has lots of resources for individuals to look. We do have training materials. We do have pictograms. So that's something maybe you could go and take a look for our clients. And this is basically a quick conclusion. So don't just monitor just because you have to. I see that many times when I go to clients to consult, previous monitoring results received, and the next day they were put into the bottom shelf. Most people not even aware of their results. So many times what I see, they are monitoring for legislative compliance, and that's all, just for in case they have a visitation from the ministry. The purpose of the monitoring is really not that. The purpose to keep our workers safe and to do something with those monitoring results. Majority of monitoring should be proactive. We do reactive monitoring too. However, we should try to be proactive when we're monitoring, so we could eliminate the hazard before it actually became a hazard. Prioritize work groups who have higher exposure to airborne hazard. Oh, I see airborne in there. It's airborne. I have to change that. Oops. I'm sorry. think I disconnect. So I'm just going here quick. Okay. So that kind of a risk assessment, that occupational exposure monitoring program is going to able to, you're going to able to see prioritize, the work group needs to be prioritized for work, for monitoring. Do something with the results. Oh my goodness, use it. That's why you do it. They cost lots of money. So if you have an industrial hygienist coming out for you to work, always use the results. You could use it for the programs, procedure, policies, JHS. That's what it is for. These are quantified data. So most importantly, we're thinking this is probably the most accurate way for us to evaluate worker exposure. Be transparent to everyone, especially to the workers. So I see that many places that the results are not actually shared by the worker. So the workers have the right to have these results. And it is so important to, if a worker actually wears a monitor, to give the data to them, the results, and also to the Joint and Health and Safety Committee. And ensure data collected are accurate, facilitate proper decisions. So I do see that again, that monitoring done in the field, but actually we don't go and look at actually the workers are wearing the pumps. Lots of time I see the pumps are hanging off the side of the drift or put in a fridge, lock box, etc. So we just want to make sure that if you do any monitoring, that the monitoring results actually reflects what the worker was exposed to. And this is just a nice picture. I just stuck it in there. It just shows that this is an example. This individual was loaded up with all kinds of equipment because I only had 1 day monitoring day with this person. And you could see that, you know, anything is possible. You could measure lots of things on one individual in one shift. So that's it for me. I try to go very quick.
That was wonderful, Judith. Thank you so much. And I just want to say a big thank you to Scott, Brent, Ralph, Daniel, and yourself, Judith. And I think we're probably close to being on time, but I'll hand, that's the finish of this part. And now I'll hand you all over to Kimberly. Thank you.
Thank you, Kevin. And yeah, I really just wanted to say a few words as we conclude our series this year, and to really thank all of our speakers today, and especially Kevin for putting this all together. And more than that, really, if you could see the thread through all the years, there's a few things that kind of had a full circle moment this year. So work on the, it used to be the diesel particulate project, and the diesel committee working group with the ODAP, formerly ODAP, and now seeing all of this come to fruition with this Airborne Hazard Management Program is really exciting. But I particularly want to hand this over to Janice in a second for some last words, because I feel like it's another really, the most important full circle moment is really what voices need to get heard. And I put in the chat, instead of summarizing the whole sessions for October, please do take a look. We started with exposures of concern, you know, and really the launch of the silica tool, and that the Airborne Hazard Management Program, we'd like to see that in more than one sector, that approach, right? And same with the silica tool, we'd like to see it in mining, we'd like to see it for countertops and artificial stone. We would like the landscape, OHCSA's landscape review and highlights of what the system is doing, you know, really a lot about to change and be looked at again. And we hope we've shown with exposures and disease and making the link, how integral these conversations around cluster investigations and what OHCOW is doing in every level of prevention, from the tertiary and the, you know, in the linking the exposure with disease, but also the secondary with early detection, and the primary with trying to create these tools and programs to prevent people from getting sick in the first place. So, you know, there's a lot going on from that report, and, you know, discussions about agreements on definitions, but, you know, will that actually address the needs? And we hope we have proven time and time again that population data is not enough, that workers' voices are the leading indicator, that we are a safe place for workers to come upstream And, I just wanted to hopefully draw that picture for you. And I know that OHCOW is involved with OCRC in looking at reports on the best way to approach this. And it will always be a number of ways. It isn't one way. But I want to hand it over now to close all of our October sessions, and especially today, to Janice Martell. And thank you all for attending. And Janice is an occupational health coordinator with OHCOW, working in the occupational disease cluster investigations. She's also the founder of the McIntyre Powder Project, assisting miners and mine workers every day who were historically exposed to mandatory aluminum inhalation treatments. So please join us, Janice.
Thank you so much for inviting me to close out not just this session, but the series. It feels like a big weight in some ways, but it's important. Some of the, the people that I met through OHCOW and through my McIntyre Powder Project work, people are very dedicated to occupational health. And many of the people that I've met have either worked in industry or have family members or people that they know and love who've worked in industry who may have gotten sick from occupational disease and that sort of thing. And it's encouraging to see people at many different levels getting involved in occupational health and safety. Sorry, I'm just trying to clear my screen a little because I can't see my own slides. And that high level involvement is very important to move things forward. But I want to bring it down to the ground level, boots on the ground level, because if we're going to create a system that actually addresses occupational disease, we have to be looking where occupational disease resides. And occupational disease resides in workers' bodies. It resides in their, ask if everybody else is seeing what I'm seeing, which is a small.
We can see the slides.
Okay?
We can see the slides fine, Janice.
Okay, I've got this meeting controls thing that's over top of my slides, so I can't see very well. And I'm trying to get rid of it, but it's not working. Okay, sorry. Occupational disease lives in workers' bodies. You're not going to find it sitting around a board table. You're going to find it in hearts, in lungs. And if we're going to have worker-informed occupational disease strategies, you need to talk to workers and listen to what they're saying to us about what they're being exposed to, what kinds of health issues they have, and we have to monitor them over their full lifetimes. Anything that we build to address occupational disease lives or dies by that one decision. Are we looking for occupational disease where it resides? And if we're not, we will not find it. And you'll see that I put in the chat a link to a trailer for 2019 PBS frontline investigation. And it was called Coal's Deadly Dust. And what that really looked at was they were monitoring the health of mine workers who were actively at work, which is great. That's good. You're monitoring to see if they're okay. But the problem with occupational disease is it often happens 20 or 30 years down the line after somebody's been exposed to something. So it happens when workers are not at work, when they are retired, when they are aging, and sometimes workers can't be at work because they're sick. And so when the NIOSH, the National Institute for Occupational Safety and Health in the States, when they were looking at a 5-year period prior to that 2019, and monitoring for lung diseases such as progressive massive fibrosis, they found 99 cases. But clinics in the Appalachians, basically in Virginia, West Virginia, and Kentucky, found nearly 2,000 cases of black lung in amongst out of work miners, because that's where those miners lived. So monitoring just workers that were at work, you were missing 95% of the actual cases that were happening. So we need to monitor workers over their full lifetimes. And if we're not talking with workers, if we're not monitoring those exposures over their full lifetimes, we will fail with whatever system you want to set up, no matter how many scientific tables or expertise coming in. That expertise gets fed by the ground level. And you know, I've been talking to workers and their families for years now, and so has OHCOW in a lot of their intake clinics. So have joint health and safety committees talking, union members talking to their workers, labor, and the community advocates who are out there who get into this because they're seeing injustices happen, like myself with my own dad. Their voices need to be heard and they need to be at that table. So it's really important to be able to move forward with this in a way that's going to actually help workers by ensuring that we're talking to workers and talking to the people who are talking to workers. So that photo that you see is from October the 3rd, 2016 at the McIntyre Powder Intake Clinic in Sudbury. That was held at the United Steelworkers Hall and in collaboration with the steelworkers and OHCOW. And we talked to workers, collected their data, talked to their estates. What kinds of things were you exposed to? What kinds of protective equipment did you have? Those kinds of that kind of information is critical. And what kinds of health issues do you have? So exposure data is half of the equation and monitoring what they're exposed to. The other half is monitoring the health outcomes. That's how you're going to catch the next occupational disease. Dirty workplaces cause occupational disease. I know that that's as blunt as I can get. So even though occupational disease may reside with the workers, it is not the workers' fault. It is being exposed to things that harm them at work that causes occupational disease. When I went to university, my majors were in psychology and law. And I remembered this Maslow's hierarchy of needs has stuck in my head for a long time. Abraham Maslow was a American psychologist, and he wrote a paper called A Theory of Human Motivation back in 1943. And his paper basically talked about we are motivated to meet our needs, and those needs come at different levels. So we can't get to the higher needs, the self-actualization, until we have our basic needs. And the bottom one is physiological. So sleeping, eating, drinking, water, those kinds of things, the things that we need to live. And in his actual paper, you see a lot of these pyramid diagrams, if you were to Google it. And in some of them, this is his 5 categories that he talks about in the going up in needs. And if you look at some of them, they'll give examples of the kinds of things: love and belonging, family relationships, that kind of thing, safety, having a shelter, having safety of person. And under physiological, sometimes you'll see breathing or air. But when you actually go back to his paper, he doesn't talk about breathing or air at that level. He's talking about food and water, basically. The body's sort of getting to homeostasis, having good salt and water balance and that sort of thing. And I think the reason that he doesn't talk about air is because air is so fundamental to life that it's a given. It's just a given in his mind. When you're in a mining environment, air is not a given. Air is something that is manufactured. If you're underground, you have to engineer air. You have to suck in enough good air that people are going to be safe and control the hazards in a mine to make people safe as well. If you're a firefighter and you're walking into a burning building, you're carrying air on your back. You're going into a building where the air is being consumed by the fire. So air is not a given, and certainly anyone working in an industrial setting and sometimes in other settings, clean air is not a given. We have to manufacture clean air. We have to control hazards. We have to allow people to breathe and to breathe safely. And one of the examples of this that is most blatant and horrific from history is McIntyre powder, which was introduced into the mining environment by the Northern Ontario mining industry and controlled by the Northern Ontario mining industry with government sanctioning. In 1926, silicosis became a compensable disease, and there was high rates of silicosis in the McIntyre porcupine mining camps in the Timmins area. So when it became a compensable disease, and the mining executives basically sat down and said, "What can we do about this?" They started doing some work with the Banting Lab, actually, at the University of Toronto, and they had their mine doctor and their mine geologist basically look into an old theory that if you put certain rocks in, there's natural antidotal rock theory, and they put a bunch of different minerals into a test tube with silica dust, and when they put in aluminum, it surrounded the silica dust. It surrounded the silica molecule, was going to prevent. They thought it would prevent the lung disease silicosis. So they tested this on 13 rabbits and 50 guinea pigs, and then they started pumping it into the mine dries where mine workers were changing. And my dad was one of those mine workers, and he ended up with Parkinson's and COPD from the aluminum dust and from other elements, but the Parkinson's was from the McIntyre powder. So not only did they not control for the dust that was already in the mines, but they actually added another toxic element into the mines. And until I started the McIntyre powder project and started talking to workers and finding out how many were getting sick and what kinds of sicknesses they had, this wasn't really investigated. There was, at least in Ontario, the previous workers, work that had been done in research work was from the early and mid 1990s, and they hadn't really touched it since then. But since that time, and since we started talking to workers and getting that information out there, and OHCOW held intake clinics, and it put more pressure to get actual research done. The Occupational Cancer Research Center did a study that showed elevated risks of Parkinson's in these workers and some other health issues as well. So I just wanted to emphasize the importance of starting at ground level and speaking with workers if you're going to be building any kind of system that's actually going to functionally deal with occupational disease. This would not have happened without workers informing the process, and you have to work with the agencies and the labor communities that are informing the process. I can say that my dad had 3 occupational diseases in his lifetime. He had white hand, which was discovered during his mining years, and Parkinson's and COPD. Parkinson's happened 10 years after he finished mining, was diagnosed, and COPD was diagnosed at autopsy. He was starting to have trouble with his lungs at the end of his life, but the diagnosis didn't actually come until autopsy. So we cannot afford to leave workers out of this equation and their voices. And that's basically what I wanted to say. And thank you very much for listening. I know we're a couple minutes over time.
That was wonderful, Janice. Thank you so much for finishing it off that way. That's why we're all here, and why we do what we do day in, day out. So did you want to close it out, Kimberly? Have you got anything else to add now, or we just close up?
No, it's all Janice. Thanks. Thanks.
Thank you, everybody.
Thank you very much, everybody. Bye.